My name is Deborah Karata. Welcome to my course, RxJS and Angular Reactive Development. As an Angular developer, you already use RxJS observables, defining a data stream every time you retrieve data using Angular's HTTP GET. You can also use RxJS to create streams for user actions, such as selections and button clicks. Merge a data stream with an action stream, bind it in a template, and watch your user interface automatically update anytime the user performs that action. It's like magic. Some of the major topics that we cover include clarifying the RxJS key terms, such as observable, observer, and subscription, using a more declarative approach to defining data streams, combining streams to merge data from multiple sources so you can display customers with their associated orders or users with their associated roles, and creating streams from user actions such as selections. Then merging the data streams with the action streams to react to those user actions, automatically updating the view as needed. By the end of this course, you'll know how to use RxJS to build more declarative and reactive Angular applications, providing your users with a more performant and interactive application. I hope you'll join me on this journey to learn RxJS with the RxJS and Angular Reactive Development course at Pluralsight. With reactive extensions for JavaScript, also known as RxJS, we leverage patterns to collect data from multiple sources, combine data for display, cache data to improve performance, and react to user actions and state changes. Welcome to RxJS and Angular Reactive Development from Pluralsight. My name is Deborah Karata, and this course provides the concepts you need to understand RxJS and use it to develop your Angular applications with a more declarative and reactive approach. When we start with Angular, we learn how to use RxJS to manage simple data coming into our application. As we work on real-world applications, we manage more data, often coming in from multiple data sources, and we handle more interactions. We need better patterns for managing state, multiple datasets, and subscriptions. RxJS is a large topic, so let's focus on key usage scenarios. The goals for this course are to add clarity in understanding RxJS terms and syntax, examine more declarative and reactive RxJS patterns, improve state management by leveraging those patterns, merge RxJS streams to manage data from multiple sources and react to user interactions and state changes, minimize subscriptions for cleaner code. Our final code has no subscriptions, and improve UI performance with better change detection and data caching. Notice that these goals do not include covering each of the RxJS operators. There are over 100 of them. We'll cover what we need to meet these goals and clarify the terminology to help you better understand the remaining operators. In this first module, we clarify what RxJS is and how it's used in Angular. Then we define reactive development. Lastly, we consider several suggestions for getting the most from this course and look at the topics we'll cover in the remainder of this course. So what is RxJS? RxJS is short for Reactive Extensions for JavaScript. Reactive extensions were originally developed by Microsoft as rx.net. Since that time, the Reactive Extensions library has been implemented for several other languages, including Java, Python, Ruby, and JavaScript. But that doesn't really answer the question, what is RxJS? According to the documentation, RxJS is a library for composing asynchronous and event-based programs by using observable sequences. What does that mean? Think of RxJS as a way to manage data as it flows through time, similar to how apples flow on a conveyor belt. First we collect, Apples are picked, hauled, and loaded onto a conveyor, creating a stream of apples. Similarly, we use rxjs to send an HTTP request and receive the response, creating a stream of data. The stream is observable. We can watch it as items are added or emitted to the stream. We pipe the stream of apples through a set of operations. As each apple flows through, we transform the apple by cleaning it, filter it by quality or size, and process it, affixing a label, for example. Likewise, we pipe our data through a set of operations to transform, filter, or process our data using query-like operators. We combine streams to merge their results. In our apple example, we combine the green apple stream with a red apple stream to create a mixed bag of apples. Correspondingly, we combine a stream of customer data with a stream of invoice data to display a customer with their overdue invoices. And we can cache the stream. This one doesn't fit as well into our apple metaphor, but when working with data, we may want to cache it in a service to reuse the data without another HTTP request. Going back to the definition, we restate this as rxjs is a library for composing observable streams and optionally processing each item in the stream using an extensive set of operators. rxjs helps us better manage and manipulate the data needed in our application. There are other techniques for managing asynchronous and event-based data. A callback is a function that can be called back after an async operation is complete, but callbacks can be difficult to manage when working with nested async operations. A promise is an object that may produce a single value sometime in the future. It can only handle a single emission and is not cancelable. Async await is a special syntax that allows writing asynchronous code that looks synchronous. It also can only handle a single emission and is not cancelable. Why use rxjs and not one of these approaches? Using rxjs has several advantages. rxjs provides a single technique for working with any type of data. We often work with multiple sources of data, events from the keyboard, mouse, or routes, and data from arrays, files, databases, or third-party APIs. With rxjs, we work with different data sources using the same techniques and operators. Our views often require data combined from several sources. We easily compose data with rxjs. rxjs can produce multiple values over time and uses a push model to notify our code when specific actions occur, making it easy for us to watch and react to user interactions or data changes. rxjs is lazy. Evaluation does not start until subscription, so we can create recipes that only execute when we need the result. For the best user experience, we want to handle errors gracefully. rxjs has built-in error handling. And with rxjs, we can cancel asynchronous actions. For example, if a user clicks on product A and then quickly clicks on product B, we can cancel the request for product A and only return product B. So many great advantages to rxjs that Angular built it in to several key features. For example, Angular uses rxjs in routing to watch for changes to route parameters, route data, or router events. In reactive forms to watch for value changes as the user modifies input elements on a form. And when communicating with a backend server, sending requests and receiving responses using HTTP client. That's why Angular installs rxjs as part of its core set of libraries. We can expand our use of rxjs in our Angular applications to move toward more reactive development. What's that? From Wikipedia, reactive development, also called reactive programming, is a declarative programming paradigm concerned with data streams and the propagation of change. As the user makes a selection, data is retrieved from a back-end server, or some other system state is changed, that change is propagated and the application reacts appropriately, updating the display or performing another action. In addition, reactive development is functional. The essence of functional reactive programming is to specify the dynamic behavior of a value completely at the time of declaration. We'll see this style of declaration in action later in this course. A reactive system is quick to react to user interactions, resilient to failure with good error handling, and reactive to state changes, meaning the code watches for change events and reacts instead of procedurally calling methods. We'll examine these concepts further as we flow through this course. For now, let's look at some tips for getting the most from this course. To get the most from this course, it's important you know the basics of Angular. This means understanding components, templates, and services, and have exposure to observables, specifically how to use them with HTTP client to retrieve data. If you don't have the requisite knowledge, consider taking one of the introductory Angular courses, such as Angular Getting Started or Angular First Look. You don't need extensive knowledge of rxjs. We'll cover what you need in this course. Another way to get the most from this course is to join the discussion. Thoughts, comments, or questions about this course? Feel free to use the discussion tab. Find the link to the discussion on the Pluralsight page for this course. Or follow me on Twitter. It would be great to hear about your experiences with rxjs and Angular. When building web applications, regardless of the technologies we use, there are often lots of steps and places things can go wrong. That's when a good checklist can help. I'll present checklists at the end of many of the modules, and we'll use them as a brief review of what was covered in that module. Feel free to jump ahead to the checklist if you have any problems when coding along with the demos. And consider referencing these checklists as you start leveraging reactive development techniques in your Angular applications. Also for your reference, at the end of this course you'll find information on common RxJS issues and how to resolve them. Coding along with the demos is another great way to get the most from this course. Though not required, it's often helpful to try out the presented code. To get you started, I've set up a public GitHub repository specifically for this course. It's called Angular RxJS. You can find it at this URL. The starter files are here. Use these files as a starting point if you want to code along with the demos. If you'd prefer to follow along using the completed code, you can find that here. If you're new to GitHub, simply click this button to download all this code as a zip file. We'll walk through installing this code a little later in this course. Now let's finish up this introductory module with a look at the outline for the remainder of this course. In this course, we cover declarative patterns and practices for using RxJS and Angular. We begin with a review of basic RxJS terms and syntax to ensure we're all on the same page. We answer questions such as, what actually is an observer? How do we create an observable? And how do RxJS operators work? We then go reactive, examining declarative and reactive patterns for retrieving data. The data we get from a back-end server or external API is often not in the format we need for display to the user. We'll map data into more relevant and useful formats. We then evaluate several techniques for combining data streams and use those techniques to map data from multiple sources. Selecting a filter should filter a list. Clicking an item should display its details. We'll look at declarative techniques for reacting to user actions. Often we want to share data between the components of our application. We'll look at a simple pattern for caching observables in an Angular service. We learn what higher-order mapping is and compare several higher-order mapping operators, such as merge map and switch map. Lastly, we see how to combine all streams for a view for the ultimate reactive component. By the end of this course, you'll have the knowledge you need to build your Angular application more declaratively and reactively with RxJS. Let's get started.
By the time we're done, you'll have a solid understanding of all the Angular elements involved in the UI layer and how to make the UI pop.
Before we can power up our skills, we need a firm foundation. Welcome back to RxJS and Angular Reactive Development from Pluralsight. My name is Deborah Kurata, and this module reviews RxJS terms and syntax. When you hear the phrase data stream, you may picture something like this, but often data is not continuous like this stream. It's more discrete, like items on a conveyor. Let's take that metaphor a bit further. Imagine you work at an apple factory processing apples. You turn on the conveyor to start the stream. Apples are collected and dumped, or emitted, into the stream. Each apple passes through a set of operations, such as cleaning, filtering, or adding a label, before it reaches you. As an observer of this stream, you'll receive 3 types of notifications. You're notified each time the next apple comes to you, so you can process it. If the machine jams, you're notified of the error, and the conveyor will stop so you can handle it. When there are no more apples to process, you'll receive a notification that you're done for the day. And if you need to leave before all apples are processed, shut down the conveyor before you go. Otherwise, the stream will continue after you're gone, making quite a mess. If you have experience working with RxJS, you may have picked up on the message in this story. Let's review this process again, but this time with RxJS terms. Before you receive any apples to process, you must first start the stream. In RxJS, we start a stream by subscribing, which starts sending or emitting data items along the stream. The apples pass through a set of operations. In RxJS, we pipe the data in our stream through a set of operators. The apples are observable, and you are the observer. As the observer, you receive 3 types of notifications: next, error, and complete. In RxJS, an observer is an object with 3 basic methods. A next method specifies the operation to perform when each item is emitted. The error method handles an error condition, and the complete method specifies the action to take when the stream is complete. And you can stop the apples at any time by shutting down the stream. In RxJS, we unsubscribe. This module expands on these concepts and covers observer-subscriber, observable stream, also known as just observable, starting the observable stream and the resulting subscription, stopping the observable stream, and creation functions. In discussing these topics, we'll use our metaphor, conceptual explanations, and Angular code to solidify these often abstract concepts. The specific RxJS features demonstrated in this module include of and from. Let's start with a more detailed look at an observer. As an observer in our apple factory, you observe the apples as they are emitted onto the conveyor. You are notified as the next apple comes to you so you can process it. You are notified of an error condition so you can handle it. And you are notified when the stream is complete, letting you know you are done for the day. In RxJS, we define an observer as an object that monitors a stream. The observer responds to notifications specified as methods. Next, to handle the next item emitted in the stream, error to handle an error condition, and complete to do any final processing or cleanup when the stream is complete. So as its name sounds, an RxJS observer observes the stream and responds to its notifications. Here are some other ways you may hear an observer described. The first is from the RxJS documentation. An observer is a collection of callbacks that knows how to listen to values delivered by the observable. Okay, that makes sense. We can think of our next error and complete methods as callbacks that respond as each item is emitted to the stream, an error occurs, or the stream is complete. This one is from the Angular documentation. An observer is a JavaScript object that defines the handlers for the notifications you receive. Here, handlers refers to our next error and complete methods. Internally in rxjs, an observer is also defined as an interface with next error and complete methods that ensures that any class created as an observer implements the three methods. One such class that implements the observer interface is a subscriber. While observer is the class we use to observe our stream, inside rxjs, each observer is converted to a subscriber. A subscriber is basically an observer with additional features to unsubscribe from an observable. We'll talk more about observables and subscriptions in a moment. Note that subscriber is rarely used except within rxjs. In our code, we normally work with an observer. Let's examine what an observer looks like in code. We said that an observer is an object that handles three types of notifications, specified as methods. We declare a variable called observer and assign it to an object literal, then define our three methods. Next specifies the method to execute each time an item is emitted to the stream. Error details the methods to execute if an error occurs, and complete defines the method to execute when the stream completes. Each of these methods are defined using an arrow function. The variables to the left of the arrow are the method parameters. The next method takes in the emitted item. The error method takes in the error. The complete method takes no method parameters, so we use empty parentheses. The expression to the right of the arrow is the method body. In this example, we simply log a notification to the console. But we rarely declare an observer like this. We'll see the more common shortcut technique shortly, but thinking of an observer as an object with three methods can help solidify its purpose. Let's look at streams next. In the apple factory, our stream is the apples moving along the conveyor. In rxjs, the stream of data is called an observable stream. We emit any type of data into an observable stream. Numbers, strings, or events, such as mouse events, key events, value changes, or routing events. We can emit objects into an observable stream, such as customers or products. Or we can emit the response returned from an HTTP request, which is often an array of objects. We can even emit other observable streams. An observable stream is also called an observable sequence, just an observable, or sometimes just a stream. An observable is the core rxjs type. Observables can be synchronous, meaning the items are emitted to the stream immediately, or asynchronous, meaning the items are emitted at some future point in time. Observables can emit a finite number of items, such as the numbers in an array, or an infinite number of items, such as a count when a timer goes off every second forever. Here again is the observer with its three methods. We could create an observable using the new keyword. In the constructor, we optionally provide a function. The argument passed to this function is the observer. The code in the function executes when the stream is started. Here we call next to emit two apple strings to the stream, and then complete the stream. We don't normally write code that looks like this. There are easier ways to create an observable stream that we'll see in a moment. But again, it's useful to examine the long-form syntax to understand these concepts. Now that we've defined an observer and observable, will this code emit two apple strings to our stream? Nope. Recall that observables are lazy and don't execute when they are defined. So what's missing? If you said we have not started the stream, you are right. Let's talk about that next. In our apple factory, you start the stream of apples by turning on the conveyor. Then apples are collected and dumped or emitted into the stream. With rxjs, we start the stream by calling the subscribe method of the observable. We must subscribe to an observable to start the stream. Otherwise, no values are emitted to the stream and we have nothing to observe. Here again is our observer and our observable. To subscribe, we call the subscribe method on the observable like this. When we subscribe, we pass in an observer to monitor that subscription and react each time an item is emitted, when an error occurs, or when the observable completes. To say this another way, as part of the subscription process, we tell the observable how we will observe it. The subscribe method returns a subscription, which represents the execution of the observable. Now that we've subscribed, this code in the constructor is executed. It first calls next on the observer, displaying the next method message in the console. It calls next again, displaying a second message to the console. Lastly, it calls the complete method, stopping our stream and displaying our complete message. So, when you hear the term observer, think set of callbacks to observe, handling next error and complete. When you hear the term observable or stream, think sequence of emitted items. And remember that a stream won't start until we subscribe. When working with observables, we don't normally create a separate observer like this and pass it into the subscribe method. Rather, we pass the next error and complete methods directly into the subscribe method, like this. The first argument is the next method, the second argument the error method, and the third argument is the complete method. Each of these arguments is optional, only specify what you need. Now we know how to start a stream and define an observer to react to its notifications, and we know how to complete a stream, effectively stopping it. But are there other ways to stop the stream? In our Apple factory, we turn off the conveyor before we leave to ensure we don't end up with apples leaking everywhere. With rxjs, properly stopping each observable stream helps avoid potential memory leaks in our application. There are several ways to stop an observable. Calling the complete method of the observer automatically unsubscribes and executes the observer's complete method. Some creation functions and operators, such as of, from, and take, also automatically unsubscribe and execute the observer's complete method. We'll talk more about this shortly. Any uncaught error executes the observer's error method and unsubscribes without calling the observer's complete method. Calling the unsubscribe method on the subscription also stops the stream. Unsubscribing does not call the observer's complete method. It simply lets the stream know that we are no longer interested in observing it, so it shouldn't emit any more items. In all of these cases, the stream stops. Let's look at the unsubscribe method. Since the subscribe method returns a subscription, we can store that subscription in a variable and use that subscription variable to unsubscribe. Properly unsubscribing from each observable that doesn't complete on its own helps avoid memory leaks in our application. So we create an observable, subscribe to start the stream, and unsubscribe to stop the stream. But is this really how we create our observables? With a constructor?
This is all fine and dandy for many use cases, but sometimes we need to take some action when a property is changed. That's when we would typically use a property setter, and there's nothing that stops us from doing so just because we're using an input decorator on the property. Here's an example. In this case, when we keep reflecting changes, we need to take some action, namely hydrate the correct person from the database. You'll notice we don't directly change the human blood
Application, we often don't create our own observables. Rather, we work with the observables Angular creates for us. But there are times we want to create one ourselves. We could create an observable using the observable constructor, but the recommended technique is to use a built-in creation function. Of is one such function. Of creates an observable using a set of defined values, emitting each value and then completing the stream. In this example, the observable emits 2 strings and completes. Or we can use the from creation function. From creates an observable from an array or other data structure, emitting each individual value from that structure, and then completing the stream. Notice the array syntax here. In this example, our observable emits two strings and completes. From is useful for creating an observable from any data structures you may have in your application. These techniques result in the same observable sequence, emitting two apples and completing. Notice that these creation functions are static functions, meaning we call them directly without an object, so there is no something.of or something.from. It's just of and from. Let's clarify the difference between the of and from creation functions. Say we have an array of apples. If we pass that array to the from creation function, we'll get two apples emitted to the stream because the from creation function takes each element in a structure, in this case our array, and emits them. If we pass the same array to the of function, only one item is emitted, the array of apples, not the individual apples. That's because the of function emits each of its arguments into the stream, and in this case, our first argument is the array of apples. To achieve the same result as the from creation function with the of creation function, we use the JavaScript spread operator. This spreads the element of the array into the of function's arguments and emits two apples into the stream. So these two creation functions are equivalent. There are several more creation functions available in the rxjs library. I'll mention two of them. From event creates an observable from any document object model or DOM event. In this example, we create an observable from click events on a paragraph element. There are easier ways to work with events using event binding in Angular, but this technique is useful if you want to combine this stream with others that want notification of the click events. We'll see more about reacting to notifications later in this course. Interval is another creation function. It creates an observable that emits a sequential number at a defined interval. This is often used to generate an asynchronous stream for test or sample code. This example emits a sequential number every 1,000 milliseconds until the stream is stopped. Let's try out a few of the creation functions.